Okay, I just wanted to quickly show a different way of using fitlm, actually the official way of using fitlm to construct a cubic model or a higher order polynomial model. Um, okay, so let me just, this is the old way, that we just saw. We constructed this input matrix, which consisted of x squared, x cubed, and then used fitlm with that matrix as the input, and then computed this cubic model. Okay, so fitlm actually has a way of fitting a cubic model without having to construct this input matrix explicitly providing the columns. In fact, probably works better if we do it the following way. So let me actually go help fitlm and show you where this is coming from. If you go up here, so fitlm blah blah blah, it says the format of the function that you're trying to fit can be provided in this manner. So if you have three inputs, and if you say x1 plus x2 plus x3, that means that it's just computing a linear model of with respect to those three inputs. If you have two inputs, x1 and x2, and then if you want all possible constant, linear, and squared terms, you say x1 squared plus x2 squared, and so on. So let me actually show you how this works here, if that's not clear. So instead of even constructing that three-column matrix, we just go x-list, which is really the only source of input. It's just we're squaring it and cubing it. And then we go y tilde x1 cubed or something, x1 cubed. This says to fitlm that we want a model that has constant, linear, quadratic, and cubic terms. That's the default assumption that this thing makes. Okay, so let me actually run this thing, and hopefully everything else will remain exactly the same. So let me run it, and that's it. It worked. Okay, so that's a cubic term, and then if you go lm underscore cubic, it actually, because we asked it to construct a cubic model doing this thing, it says intercept the x1 term, x1 squared term, x1 cubed term, and it knows the meaning of those terms. Previously, because we have three columns, it says just said x1, x2, x3. Now it basically gives you the information about what the terms, individual terms are. And then if I want to, well, do something else, let me just copy this thing here, paste it here. We get that. If you want a quadratic model, you get a quadratic model that way. Just enter the quadratic term. If you want a quintic model, looks like that works as well. Okay, so we didn't have to assemble all the columns now, but I assembled the columns and constructed the input matrix for a very particular reason that you will see in the next video, essentially, where we will find a way to essentially solve this analytically, or at least one way to solve these regression problems analytically, however many inputs we may have. Okay, that was my intention, to actually construct the matrix explicitly. Okay, let me stop this video.